All right, so we are moving into the last lesson of this chapter, which is lesson 7.5. So let me present my screen and we'll get started. Okay, there is quite a bit of vocabulary for us to go through. So the first word is a trapezoid, which I know some of these terms you are familiar with. So a trapezoid is a four-sided figure. It's a quadrilateral with exactly one pair of parallel sides. Okay, so a trapezoid looks something like this. Okay, and it could be turned sideways. I'll do a quick other. Oh, that's not a straight line. Hold on. It could be turned. The orientation can be different, right? It could be turned and look like this. All right, but it has one pair of parallel sides. So a lot of times it's the top and bottom that are parallel, but if it's changed and turned and rotated, it could be the sides, okay? So those are called the bases, and we label this one base 1 and this one base 2, or vice versa. It doesn't matter which one's 1 and 2. All right, and then we have the legs. That's a leg, and this is a leg of your trapezoid. And then we have the base angles. Base angles. So we have two pairs of base angles, okay? This right here, these two are a pair of base angles, and then the ones down here are also a pair of base angles, okay? So I'm going to kind of go through some of that vocabulary now. The bases, the two parallel sides of a trapezoid are the bases. So that's how you identify the bases. You look for the two sides that are parallel. All right, the base angles of a trapezoid are two consecutive angles whose common side is a base. It's an S. Okay. So consecutive angles whose common side is a base. So again, this is a pair of base angles, and then the bottom ones are a pair of base angles. All right, the legs of a trapezoid are the two non-parallel sides. Now, the legs may be congruent to each other, but they don't have to be congruent to each other. Okay. It depends on what type of trapezoid. So, if we're looking at an isosceles trapezoid, then your legs are congruent. So, an isosceles trapezoid is a trapezoid with two congruent legs. Okay. So, just as a quick sketch, if you have a trapezoid where the two legs are congruent, then that would be an isosceles trapezoid. Okay. Let me scroll down just to get the last two words in. All right, mid-segment of a trapezoid. We talked about the mid-segment of a triangle in the last chapter. So the segment that connects the midpoints of the legs. Okay, so if you have a trapezoid, all right, top and bottom are parallel. That's how I know it's a trapezoid. Midpoint of this leg, midpoint of this leg, connect them together. That connecting segment is called the midsegment. And we're going to learn more about the mid-segment later on, okay? And then finally, a kite. Looks like a kite is a quad, four-sided figure, where consecutive sides are congruent. Okay, so a kite, four-sided figure where consecutive sides, this side is consecutive to that, are congruent to each other. Okay. It is not a type of parallelogram, nor is a trapezoid. All right. So we have some theorems. First is the isosceles trapezoid base angle theorem. So I explained that an isosceles trapezoid has two congruent legs. Well, if it's an isosceles trapezoid, then it also has congruent base angles, just like our isosceles triangle, right, has congruent base angles. An isosceles trapezoid, these two base angles are going to be congruent to each other, and the pair of base angles down here will be congruent to each other if it is an isosceles trapezoid. Okay, we have the isosceles trapezoid base angle converse, which is just the flip, saying that if it's a trapezoid and it has a pair of congruent base angles, then it's an isosceles trapezoid. So you'd be able to figure out that the legs are congruent to each other. Then you'd also be able to figure out that angle B and angle C were also congruent to one another. Okay. The isosceles trapezoid diagonal theorem. A trapezoid is isosceles if and only if its diagonals are congruent. Okay, so trapezoid ABCD is isosceles if and only if the length or the segment AC is congruent to segment BD. All right. The mid-segment theorem, and this is something we're going to be doing some problems with in just a minute. Okay. I'll just circle this for now. All right. So MN is the mid-segment. The mid-segment is parallel to the bases, okay, which is why they drew the arrow. And then the mid-segment is the average of the sum of the bases, meaning if you take base 1 and you add to it base 2 and then divide by 2 or multiply by 1/2, that's going to be the length of the mid-segment. Okay. So I thought it was written out, but I'll write it here. All right. So the mid-segment is equal to base 1 plus base 2 divided by 2, or 1/2 times base 1 plus base 2. Okay, so you can write it either way. Get rid of that for a second. Okay, and we'll use that later on in some problems. And the last two theorems, it says for a kite, if a quadrilateral is a kite, then its diagonals are perpendicular. So you can see in the diagram that segment CA, which is a diagonal, and segment BD, which is a diagonal, they are perpendicular. They form a right angle, right? 4 right angles, 1, 2, 3, and 4. They're all 90-degree angles. And then finally, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And it's not going to be like when I think of a kite, I think about the tippy top and the tail bottom. It's not going to be those two angles that are congruent. Those are not the congruent angles. The congruent angles are, think of the kite having like the side angles, angle C and angle D, or C and angle A. All right. So it's like, think of it as the short side and the long side form to create an angle, and same with the other side. Those are going to be your congruent opposite angles. Right. Okay. So let's look at problem 2. In exercises 2 and 3, find the measurement of angle K and the measurement of angle L. Okay, so since it is a trapezoid, and I know that it's an isosceles trapezoid because the legs are marked congruent, that means that base angles are congruent. So I know that angle L is 23 because it's congruent to angle M. Now, if I need to find angle K, I can either use parallel lines cut by a transversal, consecutive angles are supplementary, or these two angles are equal, so I can add 23 plus 23 to get 46, subtract that from 360, and the leftover gets divided by 2. Okay, so it's kind of up to you. All right, so I know I'm going to write this down. The measurement of angle L equals 23. Okay. And then I think I'll do 23 plus 23 plus, I'm going to say 2x. Let's make those both x's equals 360. Okay. So that's 46 plus 2x equals 360. All right. And then when you subtract 46, divide by 2, you get x is equal to 157. Or the measurement, 360, sorry. The measurement of angle K is equal to 157 degrees. Okay, let's try number 3. For number 3, all right, it looks to be a kite, right? It's not a trapezoid. It definitely is a kite. Okay, and this angle is the one that's congruent to this angle. Okay, so the measurement of angle L is equal to the measurement of angle K. I know the 4 angles have to add up to 360, so I can say 90 plus 130 plus, and you could say 2x if you want to write 2x in this case again, right? You can label them x and x because they're congruent, is equal to 360. Okay, so you're going to have 2x is equal to 140, divide both sides by 2, and x equals 70. So that means that both of those angles are 70 degrees. And you can double check, add 70 plus 130 plus 90, make sure you get 360. All right. For the next set of problems, we're working with the mid-segment. CD is the mid-segment, and you're asked to find the length of it. Well, in your notes, I told you that the mid-segment is the average of the two bases. I'll write that out again. The mid-segment you find by taking base 1 plus base 2 and dividing by 2. So in other words, CD is equal to 12 plus 36 divided by 2. All right, 12 plus 36 is going to give you 48. And then 48 divided by 2 is going to give you 24. If you want to pause and try the next problem on your own before I set it up, that might be a good idea. Okay. Or if you want to set it up, you're going to say that the mid-segment, which is MN, is equal to base 1, which you can either do CD or AB. It doesn't matter. I'll say DC plus AB divided by 2. So that's 1.8, the mid-segment, is equal to, I don't know DC, I do know AB is 0.6 divided by 2. All right. Multiply both sides by 2 to get started, right? You want to clear out your fraction, get rid of your denominator. So I have 3.6 is equal to DC plus 0.6. Subtract 0.6 from both sides, and you get DC is equal to 3. Okay. In exercises 6 and 7, find the value of x. Okay, so number 6 is another mid-segment problem. You can see that this segment goes from midpoint to midpoint of your trapezoid. So I know that the mid-segment, 3x minus 2, is equal to the two bases, which is x plus 11 plus 3x plus 3 when you add them together and divide by 2. So it's another mid-segment formula. All right. So you can combine like terms in the numerator to start. 3x minus 2 is equal to 4x plus 14 divided by 2. Now you can multiply both sides by 2, or is 4 divisible by 2 and is 14 divisible by 2? So you can just simplify and make it 3x minus 2 equals 2x plus 7. Right? If you didn't think to do that, if you multiply both sides by 2, you'll still get the same answer in the long run. I'm going to subtract 2x from both sides. So now I have 1x minus 2 is equal to 7. Add 2 to both sides, and I get 1x is equal to 9. So I know x is equal to 9 for problem 6. All right, problem 7. I actually don't think that this was one of the theorems, so I need to go through this with you real fast. In a kite, the long diagonal bisects the short diagonal. All right. So the long diagonal is going from tippy top to tail bottom, right? That's your long diagonal. It bisects the short diagonal. So that means that JH is equal to JF. So I can set them equal to each other. 9 is equal to 1/10 x minus 1. And I can solve for x. Add 1 to both sides. 10 is equal to 1/10 x. Multiply both sides by 10. X is equal to 100. All right. And guys, I think that is it. Yep, that is it for lesson, what am I on? 7.5, the end of chapter 7. We'll obviously do more practice together in class, but that is it for chapter 7. I'll see you back here for the next lesson. Bye.